Hello! We're about to do lesson 6.4, and actually the last lesson of Unit 6, only 4 lessons long. So sweet, right? We're almost done with probability and statistics. Right about now, first name, last name, all that jazz is popping up on the screen. So thank you for filling that out. So let's jump right into it. This is slightly on the longer side, so I'm going to do my best to zip through it though, right? I'm going to do my best to zip through it, okay? So bear with me. So what are we looking at here? We want to calculate standard deviation. That was mentioned a couple in the previous 2 lessons briefly, but we're going to calculate standard deviation. So standard deviation is represented by this funky little symbol here. Represented by that funky little symbol there. X sub n represents the data points, and the x with a bar over top represents the mean or the average, and n represents the number of items, or the number of data points, I should say. Let's stick with the same terminology. Number of data points. So here is what is called a normal curve or a symmetrical curve, and this S right here stands for standard deviation. So standard deviation is a measure of spread, and it helps describe how spread out the data is. And in a normal distribution, it's honestly this beautiful, harmonious thing where the data always is spread out the same way. It's always spread out using the following percentages. 68% of the data is always here. 95% of the data is always here. And then 99.9.7% of the data is always within 3 standard deviations. Whoa. So 1 standard deviation away is 68% of the data. And we can break this up even better into, okay, this is 34 and 34, and then this piece right here and this piece right here is 13 and a half, 13 and a half, and then this data out here is 2.35 and 2.35. And then lastly, this data out here is 0.15, 0.15. Okay, don't stress about those numbers quite yet, right? But we need to have those written down. So let's just crunch some numbers. Let's first find the mean, find the average. So how do we find average? Add your numbers together and divide by how many there are. I've already pre-crunched these numbers, so you don't have to wait for me. The average is 68. Add them together, divide by how many there are. So that is our x with the bar over the top. All right. Now let's calculate standard deviation. Standard deviation is the square root of the sum of x sub n minus x with the bar over the top all over n. Okay, what does all this mean? This means to sum, and this represents each of the data points, and this represents the average. So bear with me here. I know it's going to be a little complicated at first, but we're going to add. So take the data point, 57, minus the average, 68, add it, because that's what that means. It means sum. And do the next data point, 68 minus 68, plus take the next data point. Oh, it's 68 again. 68 minus 68, plus take the next data point, 72 minus, not plus, minus 68. And take the next data point, 75 minus 68. So we added, and we did that repeatedly for each data set. X sub n represents the data points, okay? So we did it for each point, and then divide it by how many points there are. 5. I pre-crunched the numbers for you. The answer is 6.1. So standard deviation is 6.1. If you need that again, rewatch it. Okay? I'm not going to do it again because that's just going to make the video way too long. Rewatch if you need to. Okay? But a quick summary, this means sum, this is each data point. So I took each data point, subtract, plus the next data point, subtract, so on and so forth. So we can draw a pretty curve that represents this situation. We can draw a pretty curve that represents this situation. Okay? In the middle is the average, which is 68. And then we know that a normal curve, 68% of the data is one standard deviation away. So add 6.1 to 68 and you get 74.1. We just added one standard deviation. Okay? And then on the other side, 68 minus 7.1 is 6.1, sorry, not 7. Is 61.9, and we subtracted one standard deviation. So 68% of the data is right there. Okay? 68% of it. The next point on the curve is another standard deviation away. So I added another 6.1 and I get 80.2. And I add another 6.1 and I get 86.3. We're always going to do 1, 2, 3 to the right and 1, 2. So subtract 6.1 again, you get 55.8. And then subtract 6.1 again, you get 49.7. Now, I'm not pausing in the middle of this to like show you how the subtraction works, right? You can all do subtraction on your own time, but I'm just taking the standard deviation, subtracting it, in this direction, adding it once, adding it twice, and adding it a third time, subtracting it once, subtracting it twice, subtracting it a third time. So 68% of the data, or you know what, let's do the other numbers once again. So we know that 34, 34, 13.5, 13.5, 2.35, 2.35, and then 0.15, 0.15. And it's just a measure, again, don't stress about like all the specifics of the numbers, right? We're not advanced statisticians here, right? But I want you to realize that that standard deviation helps describe how spread out the data is, right? So the smaller the standard deviation, the less spread out it is. Does that make sense? Right? Because if you're only adding a teensy bit, that means all the numbers are super close together. If you're adding a really big number, well, then you're making it more spread out. That's kind of the big picture here. So the mean cost of a car is $37,500. The mean always goes in the center. Okay? The mean always goes in the middle. And then as we draw in our curve here, we're going to add the standard deviation along the way. So this next one is 39,000. I added 1,500. The next one is 40,500. I added another 1,500. And then the last one here is 42,000. I added 1,500 once again. And then I'm going to subtract going the other direction. 36,000. 34,500, 33,000. And let's fill in those percentages. 34% is here and here. 13.5% is here and here. 2.35% is here and here. And 0.15% is here and here. All right. So these questions are pretty quick if you know what you're looking at here, okay? What would be the cost of a new car that is 2 standard deviations away from the mean on both the high end and the low end? So this is 1, 2, 3. 1, 2, 3, right? So on the low end, 34,500. On the high end, 40,500. Boom. That's it. How much does 68% of the population pay for a new car? So we're able to make some really concrete observations. Based on this data, 68% of the population pays between, so this is the 68% right here, right? Pays between $36,000 and $39,000. That's a pretty finite, concrete amount, right? That's a pretty specific observation that we're able to make based on this data. So 68% pay somewhere between $36,000 and $39,000. What percentage of population would pay between 33 and 39? Well, from 33 to 39 basically just means add these together. It basically just means add them together. So that's 2.35 plus 13.5 plus 34 plus 34, and we end up with 83.85%. These questions sort of answer themselves if you draw this very accurately, okay? What is the probability that a randomly selected x value from the distribution is at least 36,000? So that means it's 36,000 or bigger. I want to show you a slight shortcut to kind of make the math a little bit quicker. 36,000 or bigger. Well, I immediately know 50% of the data is right there, right? So from 36,000 on up is 50 plus 34. You see what I just did, right? I'm using the fact that I know that this is right smack dab in the middle. I don't need to add all of this together. That's going to be a little time consuming. I very quickly know the data, 50%. Plus the smidge right there gives me 84. Okay, so notice I haven't really asked you any item pool questions yet. Well, that's because, I think that a lot of this is new. So let's see if you didn't learn something from example 2 and see if you can answer some questions for example 3. So create a normal distribution curve. So the mean is 60 and the standard deviation is 8. So we just add 8 along the way. 68, 76, 84. And we subtract 68 down the left side. 52, sorry, not 62, 52. 52 minus 8, 44 minus 8, 36. And we fill in those percentages. The percentages are the same every time. 34, 34, 13 and a half, 13 and a half, 2.35, 2.35, 0.15, 0.15. All right? So, determine the range of scores that covers 68% of the information. Let's make that question number 1. Boom. Popping up on screen, 68% of the data is between what number and what number? Probably a multiple choice option. All right, so you answered the question. 68% of the data lies between 52 and 68. What percentage of scores are above 68? So above 68 meaning 68 on up, right? Well, I'm just going to add those 3 together. That's pretty easy to do, right? So 13.5 plus 2.35 plus 0.15. And you end up with, I did this ahead of time, 16%. What percent of observations will be between 44 and 76? Let's make this question number 2 for you. Some good practice here. What percent of the data is between 44 and 76? And the answer Between 44 and 76, you can just add those up together. Or if you realize, you might have realized if you noticed up here, right? Those are both two standard deviations away. Boom, I can jump straight to 95%. I haven't drawn that every time, but it might be helpful to realize that, okay, so this is 68, this is 95, and this is 99.7, right? So from 44 to 76 is boom, 95%. Or you could have just added them together, of course. What is the probability that a randomly selected x value from the distribution curve is at most 44? So we're kind of mixing topics here, but it's all the same, right? What is the probability that percent chance probability? They basically mean the same thing as we saw in our probability lesson, right? So what is the probability of randomly selecting an x value that is at most? So only these two. 2.5% chance of picking a number, or yeah, I'm just going to say chance. I don't need to phrase some fancy sentence. 2.5% chance. If a grade of C is assigned to scores, so have you ever heard of curving a test, right? Curving a test does not mean giving everyone bonus points. Curving a test means that you look at a curve like this, and look, the highest grade practically was an 84. So what that means is that, if you got a 76 or better, you get an A. If you get this grade, so anything from 68 to a 76 is a B. These guys get a C, even though they failed, right? They got a 52%. They get a C. These guys get a D, even though they super failed, and these kids get an F. Right? You see that? That's what curving a test means. So these folks are A, B, C, D, and an F. So if a grade of C is assigned to scores between 52 and 68%, how many scores will receive a grade of C? 68%, of course, right? Because 52 to 68 is just the... So let's talk about... Yeah, I'm sorry. This one's on the longer side. Guys, I'm sorry. I just kind of... The two topics go so hand in hand, it just kind of has to be. Z-score, an observation above or below the mean of a distribution. So, okay, let's not dwell on the fancy letters. Let's just talk, okay, what does this equation say? Z-score, x is a random point, and that is average once again, and this is standard deviation, right? That fancy looking O. So, Martha scored a 22 on the ACT. What is her standard score? Which is what Z-score is, okay? So what do? We take her data point. When I say random point, I mean like one of the data points. Let me rephrase. I mean one of the data points. So Martha is a data point, right? She got a 22. Minus the average, and the average ACT score is 18. All over the standard deviation, which they told us is 6. So we get 4 over 6, or 0.6 repeating. Okay, what does this mean? What is the significance of a z-score? Well, there's this fancy table that gives us all the knowledge we would ever need. When you look at this table of standard scores and you find 0.6, we'll call it 0.7, right? 0.6 repeating is approximately 0.7 if you round it up. So that means that that means that we're in the 75th percentile. That means that Martha is in the 75th percentile. Have you ever received? We talked about this in the second video. You might remember this phrasing. Have you ever received a form or a description of like how you did on a standardized test, right? You got like your test results back and it told you, hey, you're in the 56th percentile. You're in the 89th percentile. Or maybe you've like gotten physicals, right, for sports or whatever, and your doctor tells you that, oh, your weight is in the 83rd percentile or something like that, right? Well, to be in the blah, blah, blah percentile means that you are ahead, whether that's a good thing or bad thing, of that percentage. So to be in the 75th percentile, that means that Martha scored better than 75% of her peers on the ACT, right? That is what that means. She scored better than 75% of the students. She scored better. Now, if you're talking weight, right, that means you're heavier than 75.8% of your peers. That might not be something you want to hear, right? So percentile doesn't, a high percentile is not always ideal, right? I guess it just kind of depends on your situation. So let's keep it going. If Joe's standard score was negative 1.2, what is his actual score? So we know the z-score, but what we don't know is his score, right? We know all of these details. We know the z-score, we know the average, we know the standard deviation. We just don't know his score. So we're working our way backwards. So we're going to cross multiply. So negative 1.2 times 6 equals x minus 18. Negative 1.2 times 6 is negative 7.2. Add the 18. X equals 10.8, which means he got approximately an 11 because you can't get decimals. So he got an 11 on the ACT. Not too hot. Not very good. Bill took his ACT early and found out that he scored in the 63rd percentile. What is his ACT score? So what does that mean? To score in the 63rd percentile means that he's right about here, right? Between 62 and 65-ish. Let's go ahead and say his z-score is approximately 0.35, right? The only way I can find his score is if I know his z-score. So I looked at the percentile table and realized that his z-score has to be this, and if his z-score is that, well then now I can solve for his actual score. So 0.35 equals x, because I don't know his score, but I know the average and I know the standard deviation, and we're back to doing the same thing that I just did in the problem above. So actually, with that being said, how about you try to solve for x real quick? I'm doing the exact same thing that I just did right here, right? So try that out. Question popping up on screen. If we cross multiply and solve just like above, you end up with 6 times 0.35 is 2.1, and then x minus 18. Add the 18 over, and you get 20.1. Well, you can't get a 20.1, so we'll say he had approximately a score of 20 on the ACT. We're so close to being done. I know it doesn't look like it, but some of these are super quick, and hopefully we're under 30. I'm sorry that it's long. I really am. But at least I'm posting this way ahead of time. DOHS juniors will need a 21 on the ACT in order to graduate. What does this mean? Well, let's kind of dive deep into this. What does this mean? What does it mean to get a 21? I'm doing score minus average minus standard deviation, and I end up with 3/6 or a half as my z-score. So a z-score of a half, or 0.5, puts you at 69.15%. So getting a score of a 21 means that 69% of the students did worse than you, right? So if you need a 21 to graduate, that means 69.15% won't graduate, right? If scoring a 21 means graduating, and you're beating 69% of your peers, that means 69% of them aren't graduating. Now, that's not actually a requirement, spoiler alert, but that's a scary thought to think if it were. All right, let's knock out this next page. The average math proficiency, so we're using the same equation over and over. Some more practice. The average math proficiency score is 258 with a standard deviation of 48. Answer the following questions. Joanne scored 200 on the proficiency test. What is her standard score? What does it mean? So, how about you crunch the z-score this time? You crunch the z-score. Here's her score, here's the average score, and here's the standard deviation. Plug it in and crunch the number for me. Okay, so what you should have done is 200, 200 is her score, minus the average, divided by the standard deviation. You end up with negative 1.2. So if she got a negative 1.2 standard score, that means she's in the 11.51% percentile. She scored better than 11.51% of others, right? So she's honestly in the bottom. If Mark's standard score was 1.7, what is his actual proficiency score? So I'll do this one for you real quick. He scored a 1.7. We don't know his score. Cross multiply and solve. You end up with, this is an arrow. That's dumb. Here's an arrow. We end up with 81.6, because we're cross multiplying, equals x minus 258. Add the 258, and our score ends up being 339.6. Probably more like 340. Honestly, a lot of these are the same as what we were saying before, and for the sake of time and keeping the good stuff under 30 minutes, let's skip to example 6. I'm going to have one more question. There are currently 561 juniors at Desert Oasis. Use this information to answer the questions below. Oscar is in the 33rd, maybe two more. Oscar is in the 33rd percentile. What is his class rank? So if Oscar is in the 33rd percentile, here's all the students lined up, okay? Here's Oscar standing in line. He's better than 33% of his peers, right? Well, what is his class rank? Rank is relative to the front, right? This is first place. So really, the question we should be asking ourselves is how many people are beating Oscar? 67% are beating Oscar, all right? So if 67% are ahead of him, 0.67 times 561 is, I did this ahead of time, there's approximately 300. It's sorry, I didn't do it ahead of time. 0.67 times 561 is 375.87. So that's how many students are ahead of him, which means he's approximately in 376th place. right? If that's how many people are ahead of him, he's one back at 367. You follow the logic on that? Jared and Carla are friends at Desert Oasis High School. Here comes the question. They were trying to compare their class standing. Jared is in the 85th percentile, and Carla is ranked 15th. Who is ranked higher and why? So, if we're trying to determine Jared's rank, right? If we're trying to determine Jared's rank, we need to take this percentile and turn it into a rank. So here's all the students, right? Jared's here beating 85% of his peers. What percent of kids are ahead of him? Question. What percent of students are ahead of him? Well, the answer is 15%. If Jared has 15% of the population ahead of him, while Carla is simply ranked 15th, who's in a better position? Guess what? It's going to be Carla, because if Jared has 15% of the kids ahead of him, 15% of 561 is approximately 84 kids, right? So he's in like 85th place. If 84 people are ahead of him, he's in like 85th place. Versus Carla, who's in 15th place. So Carla wins. Okay, last question. If Julie is in the top 20% of her class, how many students is Julie beating? Okay, the phrasing is different here. Percentile versus top 20%. If she's in the top 20%, she's in the 80th percentile, right? So if Julie is in the top 20%, tell me, how many students are ahead of her? She's here. Here's Julia, 20% ahead of her, 80% behind her. How many students are ahead of her? The answer, 0.2 times 561, which gives you 112.2. So basically, she's in 113th place. Oh, but it asked. Oh, sorry, I didn't answer the question correctly. I'll still, I'll still make the question for that. But I'm honestly realizing now, in the moment, how many students is Julie beating? How many is she beating? Whoopsies. How many is she beating? That's 0.8 times 561. So she's beating 449 students. 0.8 times 561, yeah, is 449. All right. Apologies for that there at the end. I'm going to keep going and finish that's the last question, but I'm going to go back up here to these three. So if you'd like to see 3 more examples, I'm going to keep going in this video, but just realize you've answered every question, okay? You can probably press submit now, I think. But I'm going to keep going here on these. Jonah scored in the first quartile. That means he's beating 25%. So he's in the 25th percentile. First quartile means 25th percentile, which means he's right, we'll call it here, at negative 0.7. So what is his score? Well, I don't know his score, but I know the average, and I know the standard deviation. And when I do the math on that, cross multiply and solve, we end up with, I'm going to skip to the point though, 224.4. In order to be proficient, you have to, proficient meaning like you pass, right? You get a passing score. You have to receive a 242. Is Jonah considered proficient? No, right? 242 is bigger than 224. So no, he's going to have to retake the test. Laura scored a 500 on the math proficiency test. What does this mean? 500, I mean, that's insane, right? But let's do the math. 500 minus 248 divided by, what's the standard deviation again? 258 divided by 48. She has a z-score of 5.04, which, if you take a look, is astronomically high, right? That's crazy. That is crazy, okay? To be way out there. So basically, she has the best score. She's in the 100th percentile. And with that, because I need to take a break after doing all this math, we did it. Thank you for watching. Thanks for answering the questions. If you made it this far, you're the real true MVP. Um, Thank you for watching. I'll see you in class. Sorry it's long. I know. I hate me too.